Hi, in this video we're going to take a look at ACT math problems that involve ratios. So we're going to take a look at the definition of a ratio, and then we're going to use a technique where we set up a table with the ratio, the multiplier, and the total. And that's going to allow us to solve a lot of different variations of ratio word problems. And then I've got 5 sample ACT problems that we're going to go over as well. So let's take a look. Alright, so let's take a look at ratios. So a ratio can either be written with a colon or the word 2. So both of these things represent a ratio of 3 to 5. So an example would be the ratio of apples to oranges is 3 to 5. For every 3 apples that we have, there is also 5 oranges. Now we don't know how many total we have, so we could have 3 apples and 5 oranges, or we could have 6 apples and 10 oranges, or 9 apples and 15 oranges. What the ratio tells us is those apples and oranges come in a set of 3 apples to 5 oranges. So if we had that same ratio, apples to oranges is 3 to 5, what would be the fraction of the total that are apples? So we're going to have 3 as a numerator, but the denominator is the 3 plus the 5, because the 3 and the 5 represents the apples and the oranges, so the total is going to be 8. So the fraction of total that are apples is going to be 3 out of 8, and the fraction of total that are oranges are going to be 5 out of 8. So now let's take a look at how we would set up a table to solve a ratio problem. So let's go back to that same ratio of apples to oranges. It's 3 to 5. And if the problem is there's 40 pieces of fruit in total with that ratio, so how many pieces of the total fruit are going to be oranges? So we're going to set up a table. The top line of the table is going to be the ratio. The second line is going to be the multiplier. And then the third line is going to be our total. And in the columns, we're going to have the 2 things that we have the ratios for, but then we're also going to include a total column as well. So to fill in that first line, we've got a ratio of 3 to 5 on apples to oranges, and then we just add those to put the total for 8. So this tells us that there's 40 pieces total. So that's going to go right down in the lower right hand corner. So the total number of pieces is 40. Then from there we can figure out the multiplier. So 8 to 40 is a multiplier of 5. So we've got to multiply by 5. So if we're multiplying the total by 5, then both the ratios also get multiplied by 5 as well. And that'll allow us then to figure out the total number of apples and the total number of oranges by using that multiplier. So 3 times 5 gets us 15. 5 times 5 gets us 25. And to answer this question, how many oranges are there? There's 25 oranges. And you can ask any variation of those pieces of information, and we can be given any of those various pieces of information, but setting the table allows us to solve all those different types of problems. Okay, so let's take a look at these 5 ACT math problems that have to do with ratios. In the first one, we've got Janelle cuts a board 30 feet long into 2 pieces. The ratio of the lengths of the 2 pieces are 2 to 3. What's the length of the shorter piece? So let's set up our table here. We've got our ratios are going to be 2 to 3, and let's add a total of 5. We're going to leave space for a multiplier, and then the total that we know is 30 feet is the overall total, so that's going to go in the last column in the total column, which gives us the multiplier of 6. 5 times 6 is 30. We've got to put a multiplier the same across all columns, and then 2 times 6 is 12. 3 times 6 is 18. They're looking for the shorter piece, so that's going to be 12. Right, the lengths of the corresponding sides of 2 similar right triangles are in a ratio of 2 to 5. If the hypotenuse of the smaller triangle is 5 inches long, how many inches is the hypotenuse of the larger triangle? So the ratio that we're setting up is the smaller triangle to the larger triangle. And that ratio is going to be 2 to 5 with a total of 7. Leave space for our multiplier. Then we have the smaller triangle has a hypotenuse of 5. So the total for the smaller is going to be 5. Gives us a multiplier of 2.5, which we're going to use on the other ones. So for the larger triangle, 5 times 2.5 gets us 12.5, or K as our answer. All right, the third problem, we've got Jerome, Kevin, and Seth. They shared a sandwich. Jerome ate half, Kevin ate a third, and Seth ate the rest. Now, in order to compare these pieces, we want to have a common denominator here. So let's change the 1/2 to 3 out of 6, and the 1/3 to 2 out of 6. So if we're comparing parts out of 6, it's going to be a lot easier to do this. So Jerome ate 3 out of the 6 pieces, and then Kevin ate 2 out of the 6 pieces, and then what's left in that for Seth is just 1. So it gives us the ratio of 3 to 2 to 1. So the trick here is putting it all in common denominator in common pieces of 1/6 rather than halves and thirds. So 3 to 2 to 1 gets us the answer of D for this. All right, in this problem we've got a graph below that shows us some information about registered voters by age. So it's asking us what are the odds, and it tells us the age range to the not in the age range. So it tells us what that ratio is that we're setting up. So we're looking at 25 to 35, which is this dark one, which is right here. So in the range, we've got 42%. It tells us the ratio we're going to do in the range to not in the range. So if we have 42% in the range, we're going to have 58 out of the range. Now ratios, this answer is not on the list. Ratios can be reduced just like fractions. So we can divide each of these by 2 and get 21 to 29, and that's going to be our answer, D. Okay, this gives us a ratio of x to y is 5 to 2, and y to z is 3 to 2. What is the ratio of x to z? So let's write this out. X to y is 5 to 2, and then y to z is 3 to 2. Now we can't compare these two because our y's are different. So let's figure out how to make it so that we have a y that we can have the same. So if this is 2 and this is 3, we could convert it to 6. So we can have a y of both 6 that we could then compare. So to make x to y, where y is 6, that's a multiplier of 3. So that's the same as 15 to 6. So the ratio of 15 to 6 is the same as the ratio of 5 to 2. Then y to z, we'd have to multiply by 2. So 3 times 2 is 6, and 2 times 2 is 4. So 3 to 2 is the same ratio as 6 to 4. Now the y's match. So now we can set up an x to y to z of 15 to 6 to 4. And then to find x to z, now we can just go 15 to 4. So our ratio of x to z is going to be 15 to 4, which is our answer, E. Thanks for watching. If you have an ACT test coming up, good luck with it. If you're new here and you'd like to subscribe, you can do so right over here. I've got other suggestions of videos for you to watch right here. Please comment below on things that you liked about the videos or ways that I can improve it. And thanks for watching, and come back again soon.